Welcome back, everybody. We are going to be making the popular game Wordle today, and we've got a couple here, and just kind of showing you how it kind of works. So, if you remember from the game, any letters you get which are in the right are in the word, but are in the wrong place. They come up in orange, like these N and an A here, and any letters that are in the word and they come up in the right place, they come up in green. So if we put in the right answer now, we can see we get the right answer there, and then we can generate a new word. So that's what we're going to make today. It's really, really easy. We can do the whole thing in 100 lines of code, and and that's quite a visual kind of representation of it. And we probably get it done in about 10 minutes. So we're going to jump in right now and get that started. Okay, so the first thing we're going to need is a list of words. So I'm going to include this list of just a whole bunch of 5-letter words with this game as well. But you can go online, you can find your own list of 5-letter words, you can make a custom one, whatever you need. So that's our word list there. I'm just going to make sure that this is saved in the same position as that 5-letter word list. So that's on my desktop. So they're both saved in the right position. Next thing, just to set it up here, I have already imported random, Pygame, and system as well. I am just importing all from the locals, and I'm initializing Pygame. Then I am just doing these RGB colors for white, yellow, green, grey, black, green, and light green. Oh, green in there twice, I need that. So you can have a little look up online if you want custom colors or whatever. You can do whatever you need to from there. But these are the colors which I'm loading and I'm going to be using, so these are RGB colors. Next, I'm loading in the fonts I'm going to use. So I'm going to use this Helvetica, which is the Wordle font, and I'm going to load it in at font size of 40, and then I'm going to do the same thing again, and I'm going to load it in as a font size of 80. These are going to be the kind of the words that come up when we win and lose. So you win is going to be using the big font. We're going to render the word you win, and we're going to render it anti-aliased, and we're going to enter it in light green. Same for you lose, and same for play again. We're going to use the regular font to actually draw the letters onto the screen and things like that. So kind of simple stuff out of the way. So the first thing we're actually going to do is we're going to create a little function here called check the guess, and that is going to take however many turns we've done. It's going to take the current word, it is going to take the user's guess, and it is going to take the window to draw it to. So the way this is going to work is that every turn we need to draw onto the next line below. So we're going to basically kind of have like a grid of squares, and as we kind of go through our turns, we're going to draw into the next grid of squares and draw into the next grid of squares, and we're going to look at how that works in a bit. So we're going to create a list, kind of like an empty list of the letters that we're going to draw. So that's an empty list of the letters we're going to draw. We're going to create a variable called spacing, and we're going to start that at 0. So the spacing variable will be the amount of space between each letter. Obviously it needs to start at a certain point, and we're going to add a constant amount to it, so we draw our letters at the same distance away from each letter. It'll make more sense when we get into it. And now we need another list, which is the guess color code. So when we don't have any of the letters, we want those all to be grey basically. And then as we guess letters, the positions in here will change colour. So if I get the first letter right and it's in the correct position, I will change this grey for a green. If I get that there is a letter in the word but I got it in the wrong position, I will change that position to yellow to signify that that letter is in there but you've got it in the wrong place. And we're going to kind of use these next two for loops to work out how we just go about doing that. So we're going to do for x in range, and we've only got 5 words, 5 letters in our word, so we're going from 0 to 5. And the first thing we're going to look at is any letter which the user has actually in the word. So we're going to do if the user guess and any letter in there, so X, so the first letter, and this will run through each letter in the user guess, is in the word that we've looked at here. We're going to take the guess color code, the same position, and we're going to make it yellow. And then, so that piece of code there is all we need to do to work out if the user has the letter in the word. Basically, we'll turn it to yellow. Now, the issue with this obviously is that this will turn it to yellow even if it's in the correct position. So this next if statement will basically overwrite it. So if the word X, so the position, is the same as the user guess X, so both of these letters are the same and they're in the same position, we're going to overwrite whatever is in the guess color code, even if it's just been changed to yellow, we're going to overwrite it to green. So now that is as simple as that. That is how we color code those two things. I'm going to use this color coding to actually draw out our grid of squares to say whether or not we are yellow or green. So obviously at the moment they're all grey, so we'll also actually look at this, we'll use this for the win condition. Because obviously if all of these turn green, it means that the user has won. So we'll look at how we do that in a second as well. The next thing we're going to do, we could have done this at any point, but we're going to take the user's guess and we're going to turn it into a list so that we can actually print it out now. And we're going to do another for loop here, so for X in range and 0 to 5 again. We are going to take our render list and we're going to print each item which is in it. So we're going to do render list X is equal to font.render. I'll explain what's happening here in a second. User guess X, true and black. Okay, so what we're doing is each of the letters that the user guesses has to be drawn to the screen. So that's what we're doing here. We're basically saying take the first, so in this instance, take the first letter from the user's guess, and we're going to basically create font.render. We're going to take that letter and we're going to render it into this render list here. So we'll basically have a list of 5 rendered letters ready to be blitted to the screen. And then what we will do next, so that will actually take our list there. We're going to draw in, so each of the letters has to be drawn into a little rectangle. So we're going to do that by doing pygame.draw.rect, and we're going to draw it to the window. And the color is going to be, so this is going to be the guess color code X. So the color of the rectangle that we're looking at is going to be the same as the one here. So if the first color is green here, the first rectangle drawn will be green. If the first color is grey, the first rectangle will be grey. So it takes this color code here that we're creating with these 2 if statements in this for loop, and then it draws 5 rectangles based on that color code in the right order. That kind of makes sense. And then we are going to actually create our rectangle from here. So we're going to draw our rectangle from here. So to draw that rectangle, I've just got it here, just clipped it in quickly. We are going to do pygame.rect, and we want the first rectangle to start 60 pixels in plus the spacing. So the spacing at the beginning is set to 0. But basically I'm going to increment that spacing as we go. And then as far as the y-axis goes, we want it to go 50 from the top plus whatever turn we're on times 80. So this one here works on the y-axis. So basically every time we take a turn, we are going to be doing 1 times 80, which will draw it further down. So let me just explain that again. We will start with drawing it 50 pixels from the top, and then turns. The first term will be 0, so 0 times 80, it'll be 50 plus 0. So that will draw the first rectangle 50 from the top. Now the next rectangle, turns, is going to increment, so this will then be 50 plus 1 times 80. Well, that's going to be 130. So in that case there, yeah, it's 130. So in that case there, it's going to draw the next rectangles 130 from the top. So we'll get so the next rectangles will be drawn on the second row. And then the next term when it comes round, that'll be 2 times 180, which is 160, plus 50, which is 210. So the third row will be drawn 210 pixels down the screen, and so on and so on. So you can see that we have that every time that we take a new turn, we draw our rectangles on a new row. And this 50 and 50 is the size of the rectangles, 50 long, 50 high. Next, we're going to just blitz this to the screen, so window.blit, and it's going to be the render list. So whatever. So this here, whatever is here, we're going to blit that, and we are going to blit it. So this is going to follow the same sort of thing as the rectangle. So I'll explain why the numbers are very slightly different. So you'll see the majority of this is exactly the same, because basically we want to draw the rectangles and then we want to draw the letters into the rectangles at the same position of the rectangles. So this is more or less exactly the same. The only thing that I found was that because the letters are slightly smaller than the rectangles, we needed to draw them slightly more to the right. So instead of starting them at 60, I started them at 70, and it tends to draw them into the middle of the rectangles. And we see the rest of it is the same as drawing the rectangle. And then we're just going to increment spacing by itself. So we're going to plus 80, so that each one, so here we are spacing, each one gets drawn 80 pixels in from the right. So the first box is drawn in the top left, and then the next one is drawn to the 80 pixels to the right of that, then 80 pixels to the right of that, 80 pixels to the right of that, and so on and so on. And then when this is run again in the next turn, the next row of boxes will be drawn, whatever I just said, 130 pixels down the screen, so it'll be underneath our first row, and then it will be again 80 pixels, 80 pixels, 80 pixels across the screen. So we kind of see it working from there. And then our final thing that we're going to do is we're going to do a bit of a win condition here. And the win condition is going to be if the guess color code is ever the same as all greens, so if it's ever the same as all greens, that means that you won. So we will return true if that's the case. And that's our function to check the guess. So now all we need to do is create the main game loop. So here we're going to start by just doing a main function, and we are going to open up our file of words. And we're going to use the upper function just to make whatever it is uppercase as well, because that will help with matching. We're then going to just make our sort of set a height and width for our window. So height equals 600, width equals 500. So I found that this to be the kind of optimal sizing for like drawing the rectangles and stuff like that. The frames are 30. We want the clock in here as well, so clock equals pygame dot time dot clock. Our so now we need to just do the window, make the window equals pygame dot display dot set underscore mode, and that takes the width and the height that we just specified. I'm going to fill the window with black to begin with, and then we are going to set our guess to an empty string, so there's nothing in there. We'll also here just print out whatever word gets selected to help with our testing. Obviously you can take this out or else it's going to be too easy when you give it to your users. So that's our main loop here. What we're now going to do is we're now going to draw, so that behind the whole screen there is a grid of rectangles. So we're going to draw that grid of rectangles. So for x in range 0 to 5 again, and we're going to do for y in range 0 to 5 again. So we're going to use a nested for loop to do this. So we're going to do pygame dot draw dot rect, and we're going to draw it to the window, and we want them to be grey, and we want to draw rectangles, so we're going to do pygame dot rect, and we're going to draw them. So when I work these out again, so this will draw them at this is the same positions as the ones we looked at earlier, so this will draw them at 60 plus whatever x we're up to times 80, and then 50 plus whatever y we're up to times 80, and then we want them to be 50 by 50, and this last one is what mode do we want them in. So if you do it as mode 2, that will draw them without unfilled in. So if you leave that without a 2, it'll fill in the rectangles for you. So we want that not filled in. We can just set the caption at the top here as well. So pygame dot display dot set caption Wordle. So that will come up at the top of our screen, and then we are going to go from here. So we're going to do turns equals 0, so at the beginning of the game no one's had a turn. Win equals false, and then we're going to do our while true loop. So this loop here doesn't really have anything to do with our win equals false. This is just going to keep on happening, and then we're going to check that that win condition. So we're just going to do a couple of event things here. So for event in pygame dot event dot get, and we are going to just check if they've closed the game. So if the event type is equal to quit, we're going to want to close the game down. Pygame dot exit system dot exit. So that will close the game down for us. And now we're going to look at all our key down events. So if the event.type is equal to pygame.keyDown, we're going to take whatever key that is, and we're going to add it into the guess that we've got at the moment. And we do that by event.unicode.upper. So this bit of code here, if you detect a key being pressed down, take whatever key press that is and place it into our guess. Okay, so it'll work if it's a Unicode. So if it's a letter there, it's going to add it into our guess. We only want our user to be able to type 5 letters in there, and we also want them to be able to use the backspace as well. So that is what we're going to be doing next. So we're going to check some specific keys here. So this is just for any keys, they're going to be added to that event. So now we want to check some specific keys. So if they want to backspace, so if event.key equals pygame.key, okay, backspace. So if they press the backspace, or the length of the guess is greater than 5, we want to take whatever is in guess and we are going to basically just remove the last character. So guess, and we're going to use just a bit of string manipulation here, and we're going to take the last character here. So basically if they type and if they type more than five letters, it's just going to keep on removing those extra letters, so you'll never get more than 5 in there. And if they press the backspace as well, it will just remove those letters. So this bit of code here will allow us to remove those letters which get put in there. We need to now just check if they press return. So if the event dot key is equal to return, we need to check, so they can only press return if the length of their guess is also greater than 4. So if the length of the guess is greater than 4, so only if they press the return key and only if the length of the guess is greater than 4 will the next things happen. So we're going to call our check guess function we made here. It's going to, if there's a win condition, it's going to pass it back into the win variable, which will turn, and if we do win, it will turn this to true, and then we'll trigger some other things from there. So win equals check guess. So I'm calling this check guess, and it takes whatever turn we're on so that we can draw it, whatever word has been generated, whatever the guess is currently, and whatever the window is so we can draw it to it. We're going to increment the turns. We are going to wipe the guess out, and then we are going to fill the bottom of the screen with black. So basically we don't want to fill the whole screen to delete everything, because what we're drawing to the screen, above where the user's typing, we want that to stay persistently. So we're just going to basically fill out the bottom of the screen. So once they hit return, it removes whatever their guess was, writes everything or draws everything at the top of the screen, and then it leaves it clean for them to now have another guess. So we're going to do window.fill, and we will fill it with black, and the coordinates of that are 5, so from 0, so on the left hand side 0, 500 pixels down the screen, and we want it to be 500 pixels wide and 200 long there. Oh, and it's just change it to black. So that will fill just the bottom of the screen for us there. We are now just going to do 2 more little if statements here as well. So in here, actually, we need to put them up here because we want to check these first of all. If the event dot key is equal to return and win is equal to true, then what we want to do is we want to run the main loop again. And similarly here, so we'll do a condition for this as well. It may be that the user doesn't want the game to run again, so we can do a condition for that. But if the turns is equal to 6, so that means that basically they've had too many turns, we're going to rerun the game again. So these two here will basically rerun the game for the user. While we're doing this, we need to be filling the filling the bottom of the screen, so where the user's typing and deleting and things like that, we need to constantly be refreshing that, dumping that with just like filling it with black, so that we don't have a load of keys being drawn on the screen, and as they're deleting in the variable, but they're still actually appearing on the screen. So we want to continually fill the bottom portion of the screen with black. So we're going to just put that into the while true loop here, so it should be in line with that for loop there. And then we're going to render the guess. So we are going to render whatever the user is guessing at the moment. So this creates, I'm using maybe the wrong term, rendering it kind of will make you think it's already displayed to the screen, but this creates a kind of a picture representation of the guess that we can then draw to the screen, and this loop here continually updates this, so whatever the user's typing will be created here, and then we can do the next line here, which is to blit it to the screen. So we do window.blit, and then we take that guess and we are going to put it at the bottom of the screen. So I worked it out to be about 180 and 530, kind of the bottom middle of the screen. And actually, at the moment, this would more or less work. So we're just going to finish it off with a quick win condition. So if the win is ever equal to true, we're going to blit this to the screen. So window.blit, and we're going to blit our bit so we're going to blit these now to the screen that we've already done. So we're going to blit that you win to the screen, and we want that to be 9200. And then we're going to blit to the screen the play again text. And we're going to do that just underneath it. And then the final bit here is if the turns are ever equal to 6 and win is not equal to true, we are going to say they lost. So the reason we do it this way is because you can actually have 6 turns and you can still win the game. So if turns equal to 6, you lose, well, you can win on your 6th turn. So you have to check if this condition is also not true, okay? We will blit to the screen. Basically, we're going to do these two things here again, but in this time, we're going to blit to the screen, you lose. And the last thing we're going to do is we're going to update the display. And then we're going to update the clock, and then that is it. We call the main, and I did it in 108 lines, but there's a bit of white space in there, and that's a bit, hang on. But we're near left there at 100 lines. Okay, so let's run it and see if it works. Okay, so first error at line 95, I needed a comma after this black here to actually get that to run. Just make sure I haven't done that again anywhere. So I've done it here as well, so we can just put a comma there as well, and that should do it. So here we go, we've got our grid drawn, we've got our correct word here, so let's try. There we go, we're typing, we're deleting, so this is all working. So let's try, like I just put in there, let's try stink first of all, so it's like think, so let's see if it just works here. Called it turns there, and then when I actually call it, I call it turns there as well, but then I call it turn here, so that needs to be turns there as well. So offer, so let's try a different word, so let's try other. So that's looking good here, so let's try and get it right here as well. So again, our play again, pygame.surface is not callable, so I reckon I've just put a comma in the wrong place here. Yep, so I forgot my comma on the play again, so let's make sure we don't do that. And I reckon we're getting close now. Can't be many more errors. So dance is the word here, so let's try dance straight away. So you win, play again, hit enter. It's trying it here. This is a weird word, so let's try early. Okay, so it's doing the orange correctly, it's doing these correctly as well. Let's try Riley then and see if it allows us to have that. There we go, so that's winning there. So lunch, so let's try punch, let's try bunch, let's try lunch. There we go. So there we go. So if you want to make your own little Wordle, you can do that right now. So Let's just try the yellow again. So it's all working. So that's as simple as that, guys. It's 100 lines of code. I'll put it all on the GitHub for you guys to grab. I hope you enjoyed that, and come back next time and we'll do some more coding.